So in this lesson, we're going to continue looking at solving rational equations, but we're going to consider a scenario that makes it so that we can't use cross multiplication. So here's an example of a rational equation where we cannot use cross multiplication. The reason I cannot use cross multiplication is because on the right hand side I have two separate rational expressions. I can't cross multiply here and here and leave this thing stranded. Cross multiplication involves everything on both sides of the equation, but it requires that you only have one rational expression on each side of the equation. And like we said, we have two here, not just one. On the left-hand side, we're okay, but the right-hand side is where we have issues. So how do we deal with that? Well, the goal is still to get rid of the denominators so that we can finish solving it like we're used to solving it. So here's how we're going to do it. We are going to multiply the entire equation by a value that when I multiply every term by it, the denominators will disappear. So what I need to do is I need to make sure that whatever I multiply my entire equation by contains everything that every denominator has in it, so that when I multiply by a value here, it cancels out all of the denominators as I multiply it into all the numerators. So the goal here is essentially to find what is called the least common multiple, or the common denominator. So least common multiple, now a lot of people get that confused with greatest common divisor. Greatest common divisor is what goes into everything. Least common multiple is what does everything go into. I've got a 2, a 1, and a 1. All of those go into 2. 2 goes into 2, and 1 goes into 2. So we're good. And then I've got an x, and x squared. I have to have at least an x squared, because x squared will go into x squared, x will go into x squared, and the other x will also go into x squared. So this is what I'm going to multiply every term by. Watch what happens. When I multiply 2x squared into the 5x, 5 times 2x squared is 10x squared, and it's over 2x. But watch what happens. 10 over 2 is 5. X squared over x is just x. It cancels out. I had the right thing multiplied in so that the denominator fully cancels out, and I only have a 5x left. Equals, if I multiply the 2x squared into the 4 now, that becomes 8x squared all over the x there. Well, again, equals, the x squared over x becomes x, and this just turns into 8x. Lastly, I have the plus, so 2x squared into 6 is 12x squared, but it's being divided by x squared. The x squared and the x squared cancel out, and I'm just left with 12. I could have multiplied a lot of different things into my equation, but this one was beneficial because it caused all the denominators to cancel out, because it's the least common multiple of all the denominators. Now from here I can finish this by subtracting 8x from both sides. I get negative 3x equals 12. Divide by negative 3. X is equal to negative 4. And there's my solution. Okay, let's practice that concept again. So in order to get rid of the denominators, I have to multiply my whole equation by something. And I can't do cross multiplication because I have two terms on the right-hand side again. Now looking at all the denominators, I've got a 3, 1, and a 3 again. So the least common multiple of that is 3. And then I have an x, x squared, and x squared. So I have to have an x squared and everything so that I have more multiples of x, or the same multiples of x in the top as I do in the bottom, so that they cancel out. So 3x squared is what I'm going to multiply in. Multiply that in here. Here's how I'm going to write that out. I'm going to go 3x squared times x minus 4 all over 3x. Now, the 3's cancel out, and the x squared cancels out one of the x's, so that I only have a single x left right here. And that x is what's going to come in. So that's x squared minus 4x is what's left over. So again, when I multiplied over here, the 3 and the 3 canceled, and one of the x's out of the x squared canceled the x in the bottom. So I had one x left. X times x minus 4 is x squared minus 4x. Equals, multiply 3x squared into 4 gives me 12x squared. 12x squared over x squared, the x squareds cancel out, and I'm left with 12. Plus 3x squared into the 6, that becomes, I believe, an 18x squared all over 3x squared. The x squareds cancel out, 18 over 3 is 6. So I end up with x squared minus 4x is equal to 18. So my denominators are gone, but what type of equation am I left with? I have an x squared, so I'm left with a quadratic. Now I know that most of the methods for solving quadratics, I've got to set it equal to 0. So I'm going to subtract 18 from both sides. And I get x squared minus 4x minus 18 is equal to 0. So I need to solve that quadratic. Now, because there's x in two different locations, I can't use the square root property method. I either have to factor or I have to use the quadratic formula. Let me try factoring first because it's easier. Negative 18. Is there anything that negative 18 splits up into? 9 and 2, 6 and 3, that adds to negative 4. It's not looking like it. It's not looking like there's anything that will do that. So I've got to use the quadratic formula. Quadratic formula, x equals negative b plus and minus the square root of b squared minus 4ac, all divided by 2a. So for us, that's going to be x equals negative negative 4, which is positive 4, plus and minus the square root of b, which is negative 4, squared, minus 4 times a, which is 1, times c, which is negative 18. And all of that's divided by 2 times a being 1. So x is equal to 4 plus and minus, let's get the calculator out. I'm going to do negative 4 squared, make sure to put the negative 4 in parentheses with the square on the outside, minus 4 times 1 times negative 18. And I'm getting an 88. 88. So it's the square root of 88, and it's all over 2. So we've got to simplify that square root of 88. So what does 88 break up into? I believe it breaks up into 8 and 11. The 8 breaks up into 4 and 2. The 4 breaks up into 2 and 2. I've got one pair of 2's, so a 2 is going to come out. X equals 4 plus and minus 2 times the square root of, now this 2 and this 2, this 11, have nothing to pair up with, so I put them back together. 2 times 11 is 22. That's what's still under the radical, all divided by 2. Now I notice that every term, I've got 1, 2, 3 terms. Every term is divisible by 2. So I'm going to divide 2 out of everything. 2 out of 4 is 2. Plus and minus 2 out of 2 root 22 is just the root 22 left. All over 2 out of 2 is 1. Divided by 1 doesn't really do anything, so I don't need it. So my solution to this rational up here is 2 plus and minus the square root of 22. So we've got one more example that we want to take a look at. This one is a little trickier though because of the denominators. They're not just a single term anymore. We notice that every denominator has 2 terms in it. So how do we deal with that? Because the goal is still to find something that I can multiply the entire equation by in order to have the denominators disappear. But before I can do that, before I can figure out what that value is, in the denominators, I need to factor if possible. This one stays as x over x minus 4. However, what I notice on this second one, x plus 3 over, I notice that both terms have a 2 in it. So I'm going to factor that denominator into 2 times x minus 4, because I divided, or I factored 2 out of each of those terms. Minus 5 times, again, that can be factorable, 2 times x minus 4. This is going to work out decently nice, because what you'll notice is that every denominator has an x minus 4 in it. So if I multiply all of the numerators by x minus 4, they're going to cancel out all the denominators that have the x minus 4s in them. But I also need to cancel out the 2, so I'm going to put a 2 here. So 2 times x minus 4 is what I'm going to multiply everything by. Now, to keep this from getting messy, here's how we need to think. When I multiply the 2 times x minus 4 times this term here, what I want you to realize is that this x minus 4 right here cancels out this x minus 4 in the denominator. So the only thing I have left to multiply together is the x right here and the 2 right there. So 2 times x is 2x. Good. Now, when I multiply 2 times x minus 4 into the second term right here, again, notice this one's going to work out really nice. The 2 cancels out with the 2, and the x minus 4 cancels out the x minus 4 in the denominator. So multiplying this in simply cancels out the denominator, and I'm left with x plus 3. Minus, here's what's great. The same thing is going to work with this last one here. What we'll see is that when I multiply the 2 times x minus 4 into this last term here, the 2 and the 2 cancel out, the x minus 4 and the x minus 4 cancel out, so I'm just left with my 5. And just like that, we had a lot of our denominator cancel out, or all of our denominator cancel out, and we're left with something really simple to work with. I'm going to write this as 2x equals x minus 2, because 3 minus 5 is negative 2. And lastly, I'm going to subtract x. 2x minus x is just x equals negative 2. And there it is. There's our solution. The solution to this rational equation up here is x equals negative 2. So let's actually do one more example, okay, to really solidify the concept from that last problem. So again, I want to multiply this equation by something that makes all the denominators cancel out. So this something right here has to contain everything that the denominators down here contain so that they cancel out. But what is that going to be? I need to first factor the denominators. So I notice that there's a p in each of these terms, so I'm going to simplify this to p over p times p minus 2. So I factored a p out of each of those. Is equal to negative 7 all over p minus 2 plus 4 over p. These two pieces here didn't need to be factored at all. There was nothing to take out of each term. So what am I going to multiply this by? Well, whatever I multiply it by has to have everything that's in the denominators in it. I notice that every denominator, well, 2 of the denominators have a p, so I need to put a p. And I also see that 2 of the denominators have a p minus 2, so I need to put the p minus 2 as well. So p times p minus 2 is what I'm multiplying everything by. So when I do p times p minus 2 in here, the whole p times p minus 2 cancels out with the whole p times p minus 2 in the denominator. So the only thing I'm left with is this p in the numerator. Okay. Now when the p times p minus 2 comes into the second term here, what we'll notice is that the p minus 2 in the numerator cancels the p minus 2 in the denominator, so I'm left with negative 7 times p. So that's negative 7p. And lastly, when I multiply the p times p minus 2 into this last term, we'll notice that the p and the p cancel out, top and bottom, so I'm left with 4 times p minus 2. So that's plus 4 times p minus 2 is 4p minus 8. 4 into p is 4p. 4 into negative 2 is negative 8. So again, simplified up really nice for us. I'm going to write this as p equals, let's see, negative 7p plus 4p is negative 3p equals negative 8. Adding 3p to both sides, that's going to give me a 4p is equal to negative 8. Dividing both sides by 4, p is equal to negative 2. So there's our solution. P is equal to negative 2.